Hello. In this section, we kind of come to the last operation that one can do with anything. So far, we've looked at polynomials, and we looked at how you can add and subtract them. We looked at how you can multiply them. And then in the last section, we looked at the special case of how you can begin to divide them by doing what we call greatest common factor factoring. In this lesson, we do what the rest of the world would call full-on factoring. And so we're going to see what that entails today. As a little warm-up, I'm going to ask you to consider the following kind of puzzles that actually tie into what we're going to be doing today. So the first thing you need to know, though, is a review of the word factor. So what is a factor of 12? A factor of 12 is a number that divides evenly into 12, meaning that there's no remainder. So what are the numbers that do that? Well, 1 and 12 will obviously divide 12. 2 and 6 will do it, and then 3 and 4. But you can't forget that all of the negatives do as well. So all of these could be positive or negative and be factors of 12. So those are all the factors of 12. Now that you know that, I'm going to ask you the following questions. Can you find two factors of 12 that add together to make 8? Can you find two factors of 32 that add together to make 12? Can you find two factors of 24 that add together to make negative 10? These types of questions are actually going to be asked today, so you kind of have to be pretty quick with some of your number sense. So let's practice it now. Pause the video now for maybe a minute and a half, 2 minutes. Unpause it once you've had a chance to try these three little warm-up puzzle questions. So pause video now, please. First question, what two factors of 12 can you add together to make 8? Well, that'd be 2 and 6. 2 and 6 multiply to make 12. That's why they're factors of 12, but they will add together to make 8. What about two factors of 32 that I can add together to get to 12? What are factors of 32? Well, 1 and 32. 2 and 16. 3 doesn't, but 4 does. 4 and 8, and I believe that's all of them. The one that we're looking for are 4 and 8. 4 and 8 will multiply to make 32 and add up to be 12. The last one, I need to multiply to make 24 because they're factors of 24 and add together to make 10. Well, if they add together to make 10, I know that they both need to be negative because I'm adding together two numbers that are negative, but they multiply to be positive. If they multiply to be positive, one has to be, or sorry, if they multiply to be positive, both have to be positive or both have to be negative. And the two that I'm looking for are negative 4 and negative 6. Those are going to multiply to make positive 24 and add together to make negative 10. Those are the types of puzzles that we're going to be looking at today, and to see why, follow along with me. So the first example that we're going to do is we're going to review how multiply worked, because if I understand how multiply works, then I can do the opposite, which is going to be divide, which we call factoring. So how did multiply work? Well, we did double distribution. Some books will reference it as FOIL to help you remember. But x times x, that makes x squared. X times the 5, that'll make 5x. Then the 3 distributes, 3 times x makes 3x. And then the 3 distributes to the 5, and that makes 15. If I combine all the pieces together, I get x squared plus 8x plus 15. Now let's look at why these numbers and the answers are what they are. Why is this 15? Because this is the multiplication of 3 times 5. Why is this 8? Because it is the addition of 3 plus 5, which are my values in my binomial. So the last term is formed from the multiplication, the product of those two numbers. The middle term is formed by the sum, or the addition, of those two numbers. Just keep that in mind. Let's try it again, and then we're going to start to turn this train backwards. I'll give you the answer and ask you what the original problem must have been. Again, distribute. X times x makes x squared. X times negative 5 makes negative 5x. Distribute the 1, I get positive 1x. Distribute the 1, I get negative 5. Combine all my like terms, I get x squared minus 4x minus 5. Again, why is this my answer? Because the negative 5 is formed from the multiplication of 1 times negative 5. The negative 4 is formed from the addition, 1 plus negative 5, which are the two values in my binomial. So you can kind of see how this game is going to be played. Now what we're going to do is imagine I gave you this and asked you to work backwards. You would need to think what numbers multiply to make negative 5 and add up to make negative 4, and that would tell you what the two factors what must have been. If you need a geometric interpretation of the tiles, this is what it looked like. Now we're going to work it backwards. Imagine this is the original problem, and I want to know what the factors are. If you think back to the tiles, it'd be like, imagine that I gave you x squared 5 x's and 6 ones and asked you to start to rearrange these in such a way that they would make a rectangle. So we'll check our answer once we get it, but here's the idea. I know from the following ones that this last number is formed from the multiplication of the two factors. So I know this is going to be x and x. The question is, what are these numbers right here? Well, I know that these numbers always multiply to make the last part a 6, and they're going to add together to make a 5. So I think to myself, what numbers multiply to be positive 6, add up to be 5? And there are some clues. If it multiplies to be a positive, that means they're both positive or both negative. So that means it's 1 and 6, 2 and 3, or it could be -1, -6, -2, -3. But it can't be any case where they're opposite in sign, because then they would multiply to make a -6. Now they need to add together to make a 5. And if I go looking, 1 and 6 adds together to make 7. -1 and -6 adds together to make -7. -2 and -3 add together to make -5. The only one that does it is 2 and 3. So this has to be x plus 2, x plus 3. In the order in which you write these does not matter. You could write it as x plus 3 times x plus 2. It's the same thing. Multiplication is what we call commutative. The order in which you multiply does not matter. What it means down here is if I were going to reorganize these algebra tiles, here's my x squared, I would need to do, well, the two factors are 2 and 3. I need to do 2 on one side, and then I would need to do 3 on the other in order to make a rectangle. I couldn't do it, for example, using the 5. I couldn't do 1 and 4. That would not make 6, because 1 and 4 would not multiply to make 6. So now I can see I've got a gap down here. What is this gap? This little grid. Well, I need 6 ones, and that's exactly what these are. Those would fit in right down there. So it shows I need x plus 2 and x plus 3 in order to get my original. How can you check your work? You can always multiply. If I multiplied backward, x times x, that'd make x squared. X times 3 would make 3x. Then the 2 would distribute. I get 2x. And then 2 times 3 makes 6. And look, 3x plus 2x makes the 5. 2 times 3 makes the 6, and it checks out. So my factors are x plus 2 and x plus 3. I'm going to ask you to try the game. So can you factor this? Can you go backwards? Can you tell me what the original factors, what the original binomials must have been? You know it starts out with x and x because they have to multiply to make x squared. But what are these two items? And realize they need to multiply to make the last term, add together to make the middle term. Maybe pause the video now for a minute, unpause it once you've had a chance to do this quick check-in. Okay, welcome back. You'll realize if it multiplies to make a positive 12 and adds up to make a 7, they both need to be positive. So your options are 1, 12, 2, 6, 3, 4. 1 and 12 add together to make 13, so it can't be that. 2 and 6 add together to make 8. It's got to be 3 and 4. X plus 3, x plus 4. Or you could write it the other way around. Doesn't matter. But there's what the tiles will look like. X plus 3, x plus 4. That's what would make x squared. 1, 2, 3, 4, 5, 6, 7 x's and 12 ones. So x plus 3 and x plus 4, or like I said, you could write it as x plus 4 times x plus 3. It'd be the same thing. What we're doing is we're practicing rewriting the equation for a quadratic. Quadratic is any equation that has a power of 2. We're writing it in right now what's called factored form, taking it from standard form. Standard form is when it's all written out, and then writing it in factored form. Factored form is like the dimensions of the rectangle, and standard form is like listing out all of the pieces that make out the rectangle. Both are valid ways to describe the rectangle. So factored form is when we write it as the product of polynomials, x plus 9 times x plus 2. Standard form is when we write it all out in expanded form, writing it how many x squareds, how many x's, and how many single ones. Notice though, these are actually the exact same equation. We'll see later if I asked a graphing program to graph them, the graph would be exactly the same. I know because 18 is the multiplication of 9 and 2, and 11 is the addition of 9 and 2. So that would be the factored form. The steps to getting it into factored form are to first do greatest common factor factoring, kind of simplify, that's what we did in a prior section, and then use what we learned today. I know that it has to multiply to make the last term, so I need to find two factors of C. Factors are numbers that multiply to make C, that also add up to be B. So it has to multiply to make C and add up to be B. Let's give it a try. Step one is look to see, is there anything I can divide out with greatest common factor factoring? Nope. There are no x's I can divide out of everything because everything doesn't have x's, and there's no numbers that are all in common. So step one is done. We'll see ones later that will have an involved step one. Now I need to find two numbers that multiply to make 5 and add up to be 6. They multiply to make a positive and add up to be a positive, so they both have to be positive. And the only numbers I know that multiply to be a positive 5 that are also both positive are x plus 1 and x plus 5. You can write it the other way around if you'd like. You could write x plus 5 first. If you want to check, you can make a multiplication table. X plus 1, x plus 5, x squared, 5x, 1x, and 5. If you add up all the pieces, x squared, 6x is plus 5, it checks out. So you'd be done. There's what the tiles would look like as well. You could also do double distribution and check that it makes x squared plus 6x plus 5 as well. Try another one. Step one is do greatest common factor factoring. Simplify first. You'll notice that this one actually has something I can divide out of everything. If I look, what number can I divide out of 2, 6, and negative 20? They're all divisible by 2, so I'm going to divide out of 2. However, if I look x squared, x, and no x's, they all don't have x's, so I can't divide an x out. All I can divide out is a 2. What's left behind? Well, if this was originally a 2, now it's a 1x squared plus a 3x minus a 10. They all get divided by 2 because I divided a 2 out. Now I'm on to step 2, which is after I do greatest common factor factoring. I factor inside of here. I need to find two numbers that multiply to make negative 10 and add up to be 3. Now here's some clues. I know it multiplies to make a negative, which means those two numbers need to be opposite in sign. It adds up to be a positive, which means the bigger number needs to be positive. So it's going to be a plus, x plus something, and x minus something. Now what multiplies to make negative 10? I could have 10 and negative 1. I can't have negative 1, or sorry, I can't have negative 10 and 1 because the bigger number, like I said, needs to be positive in order for them to add together to be a positive 3. My only other option is going to be 5 and negative 2. These do not add together to make 3. 5 and negative 2 do. So it's x plus 5, x minus 2. And I'd be done. If you want to check, I can do x plus 5, x minus 2. I'll need to double everything at the end in order to make the original because there's a 2 out front, but that's okay. X squared, 5x minus 2x minus 10. That makes what? X squared plus 3x minus 10. If I double everything in there, I'll get back to the original. So that is the correct factorization of it. I'm going to do one more, then I'll give you a chance to try. Step one, do greatest common factor factoring. Is there anything I can divide out? Nope. There's no numbers that all of these have in common and no x's, so step one is done. Now I need to find two numbers that multiply to be a positive 3 and add up to be a negative 4. Well, check this one. This one, they multiply to be positive, so that means they both either need to be positive or both negative, but they add up to be a negative 4, which means that they actually both have to be negative because there's no way for two positive numbers to ever add together to make a negative 4. So my only options, if they multiply to be a positive 3 and add up to be a negative 4, are negative 1 and negative 3. Those will multiply to make a positive 3 and add up to be a negative 4. So my factors are x minus 1, x minus 3. And you could write it the other way around. If you want to write this as x minus 3 times x minus 1, you're all good. If you want to check, you can do double distribution, or you can make a little table. X minus 1, x minus 3, x times x is x squared, minus 1x, minus 3x, negative times a negative is a positive, and look, x squared minus 4x's plus 3, it checks out. So that's the correct factorization. I'm going to give you a chance to try, just one for you. Try to factor this one. This one's got positive and negatives to deal with, so you give it a go. Pause the video for maybe a minute and a half, unpause it once you've given it a try and want to see what the correct answer is. Okay, welcome back. Here we go. First thing is you try greatest common factor factoring. There's nothing to divide out, so now we're on to, I need to find two numbers that multiply to make negative 16 and add up to be 6. Well, if they multiply to be a negative 16, I know that they're either both, well actually I know that they both have to be, they have to be opposite in sign. Because if they're multiplying to be a negative, one has to be positive and one has to be negative, and the bigger number needs to be positive because it adds up to be 6. So I think, well, it can't be, let's see, it can't be -1 and 16 because those would add together to make 15. The only other option is -2 and 8. Those will multiply to make -16 and add together to make 6. So there's my factors. X minus 2, x plus 8. Again, if you wrote it the other way, that would be just as acceptable. The order in which you write those does not matter. 5 times 10 is the same as 10 times 5. The order of multiplication doesn't matter as long as we're just multiplying two things. So there you go. That is how factoring works. That is it. Thank you very much. Have a good day.